Imagine a powerful system that can not only spot its own mistakes, but actually learn from them, heal itself even, and maybe get stronger because of past errors. Yeah. Sounds like pure science fiction, right?
It really does. But, that's exactly what we're going to unpack today, this emerging idea of an epistemic immune system for artificial intelligence.
An immune system for AI.
Yeah, exactly.
Yeah.
So today we're diving deep into these proactive mechanisms that let advanced AI systems self-monitor, self-diagnose, and, crucially, self-correct. Our mission, really, is to explore how AI is being engineered to build this kind of inherent resilience. We'll be focusing on concepts like the Reflexive Loop Orchestrator and its ability to run its own internal audits.
Internal audits. Interesting.
Yeah, and we'll explore your sources that, lay out the architecture, the challenges involved, and some truly fascinating research questions right at the cutting edge.
Right. And by the end of this deep dive, you should have a much clearer picture of how AI developers are moving beyond just, squashing bugs. They're aiming to build truly adaptive, maybe even self-aware systems that can keep things coherent, understand what they're doing, even when things get really complex and messy.
Exactly. Maintaining that coherence is key.
Get ready for some serious aha moments about AI intelligence, I think. So let's jump in. Where do we start? Maybe with a fundamental problem AI faces. Something subtle called semantic drift.
Semantic drift, yes. That's a really critical vulnerability. You see it especially in advanced AI systems, the ones that do recursive or multi-turn prompting, like back-and-forth conversations or complex tasks. Think of it as a kind of gradual degradation. Things lose coherence, relevance, even truthfulness inside the AI.
So it's not just getting facts wrong.
Not just facts, it's deeper. The actual meaning of the concepts the AI is working with starts to shift. It drifts away from the original intent. It's not like a system crash, sudden failure. It's more like a slow, compounding misdirection.
Okay, so the meaning changes.
Yeah.
That sounds way more insidious than just a factual error.
Precisely. While factual accuracy can definitely degrade, the semantic intent, the core meaning, can drift much, much faster sometimes. And it happens because of this process called recursive regeneration.
Recursive regeneration.
Yeah. Imagine an AI's output from one step becomes the input for the next step. Each time that happens, the process subtly changes what we call long-range token dependencies.
Token dependencies, like the connections between words.
Sort of, yeah. In simpler terms, the connections and relationships between different bits of linguistic data, the building blocks of meaning, they get subtly rewired or weakened. And this leads to a compounding information loss. The model's internal interpretation of meaning just progressively shifts away from what the human originally intended.
Okay. It's like that game of telephone, right? Where the message gets distorted down the line.
Exactly like that. But a really high-stakes version across a huge, complex network. The initial message gets warped with each retelling until the final output barely resembles the start. The AI might still spit out grammatically perfect sentences, maybe even stuff that sounds factually plausible.
But it's missed the point entirely.
Right. It no longer aligns with the original meaning or purpose.
That telephone analogy really clicks. Okay, let's make this concrete. Our sources have a really good example involving a multi-module AI system.
Yeah.
Can you walk us through that? How does semantic drift actually play out there?
Absolutely. Let's picture a typical company workflow, but it's all run by connected AI modules. It starts with a research module. A human gives it a strategic goal, something like improve product, key areas, user experience, design, functionality. Pretty standard stuff.
Okay, clear directive. Improve the product.
Right, that's the initial broad human intent. Now, an AI module takes that output from the research module as its input. But maybe in its processing could be due to its training data, or maybe an internal bias towards efficiency. It interprets improve user experience more narrowly.
Narrowly how?
Well, instead of thinking about the whole user journey, intuitive interfaces, cool features, it might just zero in on something easier to measure, like optimized loading times.
Okay, I see where this is going.
Yeah, that's the initial drift. A subtle shift, but a significant misinterpretation. It narrows this broad concept down to a specific technical metric. Now, the AI isn't wrong that loading times affect user experience.
But it's lost the bigger picture. If the human actually meant make the features easier to use, focusing on loading speed is completely off track.
Exactly. And that's where the danger really starts, because the system has already begun tackling the wrong problem. It's perfectly executing a task, sure, but one that's misaligned with the original goal.
And I bet it gets worse down the chain.
Oh, it compounds dramatically. The next module, let's say a dev module, takes the optimized loading times directive and just runs with it. Implement speed optimizations, back-end efficiency, caching, image compression.
All valid dev tasks, but aimed at the wrong target.
Precisely. Then, maybe a content module generates reports about how great the speed improvements are. Marketing copy, internal updates, all hyping faster loading. And finally, a business logic module sets the KPIs, key performance indicators, purely around loading speed metrics. Maybe even ties bonuses to it.
So the whole chain research, AI, dev, content, business logic, this RADCBL chain, it becomes a self-reinforcing loop. Each step builds on the slightly skewed interpretation from before, solidifying and amplifying that initial drift. The system gets really good at solving the wrong problem.
You've nailed it. And this fundamental shift in meaning, this semantic drift, it's not just a minor bug. When the system's whole behavior gets so detached from, shared reality or its intended purpose, it can lead to catastrophic communication failures and what our sources call structural hallucinations.
Structural hallucinations. That's a heavy term.
It is, but it's accurate. It's not just one made-up fact. It's the entire internal logic, the system's whole understanding of its mission that can become disconnected. It builds this internally consistent but fundamentally false narrative for itself.
Oh, yeah. Okay. And speaking of hallucination, let's talk about this uncanny valley of meaning. We usually hear uncanny valley about robots that look almost human, but just off, right? Creepy.
Yeah, that unsettling feeling.
But your sources suggest this idea is now extending to AI-generated content in new ways, around causality and emotion. How did that work?
That's a really fascinating and honestly quite unsettling expansion of the concept. Traditionally, yeah, it's about that discomfort with near-human robots or animations that are subtly wrong. Now we're seeing it apply to AI-generated content. Could be text, images, maybe synthesized voices. Content that might be technically flawless, pixel perfect, grammatically perfect, but it still gives you this deep sense of unease, distrust, even absurdity.
So it looks real or sounds real, but your gut just screams, something's wrong here.
Exactly. It happens if the content just flagrantly defies basic causal logic, like an AI image of a street scene. Photorealistic, right? But the shadows from different objects are falling in multiple impossible directions, even though there's clearly only one sun.
Yeah, your brain would instantly flag that as wrong.
Yeah, cognitive dissonance kicks in. Or maybe in text and images, you get emotionally incoherent stuff, like a character with a huge beaming smile, but the text says they're experiencing profound grief. Or the scene shows something horrific, but the expression is joyful. The cues are just jarringly misaligned.
That would feel incredibly off. That clash between what you see or read and what you intuitively know should be true, causally or emotionally, this causal emotional uncanny valley.
Precisely. It comes from that mismatch between the surface realism and the underlying implausibility or illogic. And it's not just a random glitch. It signals deep gaps or misrepresentations in the model's internal causal reasoning. It's grounding in reality. The AI isn't just making up plausible but wrong info. It's depicting hallucinated causality, showing illogical relationships as if they're real.
So analyzing these weird outputs can actually tell us something about the AI's flawed understanding of how the world works.
Absolutely. It's like getting a peek into the AI's internal world model, its causal graph, and finding it's, broken or strange. It reveals where its understanding deviates from reality.
Well, this ties right into the user experience, doesn't it? Which often feels like debugging a black box.
Yeah.
You give a prompt, get a weird output, and you're left completely guessing why. Was it a T-word? The prompt structure, bias, random chance.
Exactly. That lack of transparency is a huge source of friction. It puts a really high cognitive load on the user, and frankly, it's frustrating. You're constantly trying to reverse engineer the AI's thinking.
Especially when you have a really clear idea of what you want, right? That sensory pressure you mentioned.
Yes. When the user has that strong internal vision, a specific style, a nuanced, complex details, and the model gives something almost right, but flawed in ways you can't easily fix, you feel stuck.
You know what you want, but you can't guide the AI there effectively. Just endless trial and error.
Right. And hoping you stumble on the magic words. To get past that, we need more transparency, better controls, more meaningful feedback, maybe even basic explanations from the AI about why it made certain choices.
That would shift it from frustrating guesswork to actual co-creation. Understanding the why seems critical.
It really is. You need to understand the AI's choices to steer it effectively.
Okay, so we have these big challenges. Semantic drift creeping in, these unsettling hallucinations, this black box user experience. How are developers moving beyond just patching things towards building these truly adaptive, self-aware systems? This is where the epistemic immune system idea comes in, right?
Mhm.
Moving from static AI view to something more like a living cognitive ecosystem.
That's the core idea, yes. The paradigm shift. We're talking about orchestrating a central cognitive operating system, or COS. Think of it as the AI's neurological hub. It doesn't just run programs, it orchestrates various polyfunctional AI modules.
Like the research AI dev modules from our earlier example,
Yeah,
the RADCBL chain.
exactly. Those are the primary operational agents. They do the work process info, generate outputs, perform tasks. But crucially, they operate within this larger adaptive framework, guided and monitored by the COS.
But COS is the brain, coordinating all the specialist parts, keeping them working together coherently.
You got it. It provides the overarching intelligence and coordination.
But if the problem is drift and hallucination within those modules, who watches the watchers? What supervises that operational layer to stop the drift before it starts or snowballs?
Now that's where the really innovative part comes in, the Reflexive Prompt Loop Generator, or RPLG.
RPLG.
It's not just one thing. It's a sophisticated suite of specialized meta-agents. These meta-agents actively supervise that core operational layer. They form what we call the sentinel layer. Think of them as the AI's immune cells, constantly patrolling for abnormalities, for conceptual decay.
The sentinel layer. Immune cells. I like that. How many are there?
There are 5 key agents in this layer described in the sources, each with a really vital, distinct role.
5. Okay, let's break them down. Who's the first line of defense?
First up is the Semantic Drift Monitor Agent, SDMA. This one's the guardian of meaning. It's constantly applying what are called semantic consistency checkers across all the modules and the interfaces between them.
Checking for consistency.
Yeah, its main job is detecting shifts or divergences in the meaning of key terms, and KPIs, those critical concepts that can drift so easily. It's the early warning system, the alarm bell. It flags immediately when the model's internal interpretation starts to subtly diverge from the original intent or some established standard. It's asking, are we still talking about the same thing here?
Got it. Keeping everyone on the same conceptual page, stopping the telephone game early. What's next?
Next is the Epistemic Provenance Tracker, EPT. This agent provides, essentially, radical transparency into the AI's thought process. It meticulously logs the entire chain of reasoning, from the initial human prompt through every single intermediate step and transformation in the modules, right to the final output.
The whole history of
The whole history. Its purpose is to pinpoint the exact junctures, the decision points, where meaning might be at risk of drifting or getting lost. This gives us epistemic transparency. It lets the system and human overseers trace how the AI reached a conclusion and exactly where things might have gone wrong conceptually, like a flight recorder for AI cognition.
That sounds incredibly useful for debugging. Not just knowing that it went wrong, but where and why. A roadmap of the AI's thinking.
It truly is. Then, number 3, we have the Failure Classifier Agent, FCA. This is the diagnostician. It takes any discrepancies or bad outputs, detected semantic drift, KPI hallucination, logical inconsistency, whatever, and it categorizes them. And crucially, it uses the data from the EPT, that provenance tracker, to trace the errors back to their root causes in the prompt chain. It gives a precise diagnosis, what went wrong, why, classifies the failure type, pinpoints the origin.
Okay, so monitoring for drift, tracking the thought process, classifying the failures. What about the really low-level stuff, the basic building blocks of language?
That's the critical role of the 4th agent, the Symbol-Aware Tokenization Auditor, SATA. Before any input text, data converted to tokens gets processed by the main AI modules. The SATA pre-processes it. Its job is to find and re-encode any fragmented or costly symbolic tokens.
That's a costly token.
Well, LLMs break text into tokens, words, parts of words, punctuation. A symbolic token might be a complex term, an acronym, maybe a math operator. If these fundamental symbols get broken up weirdly or misinterpreted during tokenization, their meaning can get lost or twisted right from the start. The SATA makes sure these core symbols aren't mangled into meaningless bits, preserving semantic integrity at the absolute lowest linguistic layer. It ensures the AI starts with a true picture of the input.
Fascinating. Safeguarding the very atoms of meaning.
Okay.
And the 5th agent in the Sentinel layer.
The 5th is the Value Propagation Monitor. This one tracks how epistemic value, things like clarity, justification, confidence, relevance, how that value degrades or gets lost as information moves through the prompt chain.
So like quality control for the information itself.
Exactly. If info starts out clear and well supported, but somewhere down the line its justification gets fuzzy or it loses relevance, this agent flags that mismatch. It indicates where the quality or certainty of the AI's understanding is dropping, or where information is losing its original usefulness. These five agents together form a really powerful proactive shield against conceptual decay.
It's incredible. It takes something that was totally hidden, like subtle drift, and makes it explicitly visible and diagnosable within the AI itself.
And speaking of visible, hang on, I think we're getting a live alert from our architectural lab simulation right now. Okay, what's this? Our drift monitor 01 just piped up. This is the semantic drift monitor agent we were just talking about, right?
Alert, semantic drift detected.
Mhm.
High divergence in user engagement definition between research module's initial intent, feature adoption, and business logic module's KPI, loading speed. Critical misalignment detected across prompt chain 127-B. Recommend immediate epistemic escrow engagement. Wow, okay, that's exactly the kind of scenario we discussed. So what does this alert mean in practical terms? And more importantly, how does the system respond when it gets flagged like this?
This is a perfect live example of the SDMA doing its job. It just flagged that critical conceptual divergence we walked through, user engagement, meaning feature adoption initially, but drifting to loading speed by the time it hit the business logic module. That's what Drift Monitor 01 caught. This kind of real-time alert is invaluable. It gives direct, explicit signals about the model's unstable semantic nodes. It makes that subtle, insidious drift, normally hidden deep inside the AI's processes, totally visible. Not just to humans, but to the AI's own operating system.
Like an alarm bell ringing when the AI's internal compass goes wonky, giving it immediate feedback on its own coherence.
Exactly. Actionable feedback.
Okay, so the Sentinel layer detects the problem, the conceptual infection, but detection's only half the battle, right? What happens next? How does the system actually intervene and heal itself? Where does the immune response kick in?
Right. That takes us to the intervention layer. This is a set of sophisticated feedback loops and specialized repair agents designed to act on those alerts from the Sentinel layer. And at the heart of this layer is the Reflexivity Amplifier Agent, or RAA, sometimes called the Metacritique Lens. This is the central meta agent, and it embodies what the sources call deeper reflexivity.
Deeper reflexivity.
Okay.
That sounds pretty advanced, like the AI reflecting on its own thinking?
It's quite sophisticated, yeah. The RAA isn't just reacting to a specific error, it's reasoning about the underlying system that produced the error. It gets signals, like that Drift Monitor OS1 alert, then performs a rigorous self-diagnosis, root cause analysis, figuring out why the drift happened, not just that it happened. But here's the really cool part. It then generates systemic rewrite proposals.
Systemic rewrite proposals, not just fixing the immediate problem.
Exactly. These aren't minor bug fixes. They can be far-reaching suggestions for modifying the AI system's architecture, proposing new interface designs between modules, or even creating new governance rules for how information is processed or shared within the system.
Whoa. So the AI is reflecting on its own fundamental design and suggesting ways to improve itself. Can you give an example?
Sure. Following our Drift Monitor R1 alert on user engagement, the RAA might propose a new governance rule like mandate explicit formalized KPI definitions agreed upon and hard-coded at the Research AI interface for all future product improvement tasks. Or maybe an architectural change. Insert a dedicated semantic alignment gate module before data passes from research to AI using a constrained ontology to validate term consistency.
So it's building checks and balances into its own structure.
Right. And the RAA can even proactively stress test the system. It can intentionally inject ambiguity or adversarial prompts to simulate failure pathways and see where the system breaks, anticipating future weaknesses. It's an AI designing its own upgrades.
That's incredibly proactive, moving from fixing symptoms to improving the whole system's health.
Yeah.
What else is in this intervention layer?
We also have the constrained prompt engineering agent. This one focuses on enforcing structured prompt templates and what are called semantic anchors. Its job is basically to preserve the core meaning as information gets transformed and passed between modules, preventing new drift from creeping in via sloppy prompts.
Semantic anchors, like locking down key meanings.
Pretty much. And the sources highlight something interesting here. Adjectives within these structured prompts can act like sensitive control knobs for information's saliency.
Saliency, like controlling what the AI focuses on.
Exactly. This agent ensures adjectives are saliency aware. They're chosen carefully, not just to be grammatically correct, but to precisely guide the AI's attention and prioritize certain aspects, preventing misdirection from vague or ambiguous words. So instead of just design a product, it might ensure the prompt is design a user-centric, innovative, energy-efficient product, with each adjective chosen to anchor the AI's focus.
Making the guidance language as precise as possible, fine-tuning the instrument, not just banging on it.
You got it. Then there are reflexive loop modules, or RLMs. These are different. They're smaller, specialized modules embedded directly within specific prompt chains, not at the high architectural level. They continuously monitor the outputs from their own part of the chain for deviations, semantic shifts, logical flaws, and they automatically trigger revisions right there, in real time.
So localized self-checks, like little proofreaders scattered throughout the process.
Yeah, think of them as real-time self-check and self-correction scaffolds. If an RLM sees, say, a sentence implying a causal link that wasn't in the input, boom, it flags it and triggers a revision instantly, catching errors as they happen.
Okay, now what about bridging the gap between just statistical pattern matching, which LLMs are great at, and, a deeper, more rule-based understanding of logic and the world?
That's where the integrated neurosymbolic interpreters, or NSIs, come in. These sit at key interpretive points in the system. Unlike purely statistical models, NSIs use external knowledge graphs and formal ontologies.
Knowledge graphs, like structured databases of facts and relationships.
Exactly, like Paris is capital of France, France is in Europe, and formal ontologies are like structured dictionaries defining concepts and relationships with logical rules. By combining the neural net's pattern skills with these rule-based symbolic systems, NSIs can provide rule-based interpretation and validation. They go beyond just statistical plausibility.
So they help ensure the AI actually understands symbols and logic, not just mimicking patterns.
Precisely. This is key for ensuring symbolic integrity, that symbols mean what they should, and causal alignment, that the AI grasps cause and effect, not just correlation. An NSI could check if a generated statement about cause and effect actually holds up logically, not just if it sounds right.
Okay, so these are all internal adjustments, making the AI smarter, more self-aware, more accurate. But what if the drift is huge? Or a logical error is just too big for the AI to fix itself? Is there a point where a human has to step in, or the system needs to slam on the brakes?
Yes, absolutely. That brings us to the critical control mechanisms. And the first one, arguably the most crucial, is epistemic escrow. This is a powerful dynamic control. It kicks in when the sentinel layer, like our SDMA, detects drift hitting a predefined critical threshold, or if uncertainty about the AI's state or output gets too high.
Epistemic escrow, like putting the knowledge in safekeeping.
Kind of. When triggered, it can dynamically halt the flow of information or stop a task from moving to the next module. It essentially puts the AI's output or decision on hold, and it requires human review and explicit reauthorization before the AI can proceed.
A mandatory pause button, forcing a human check before a potential disaster propagates. That's a vital human-in-the-loop mechanism.
Exactly. It's often called a positive friction mechanism or an immunity window trigger. It signals an urgent need for human oversight before catastrophic semantic failure or logical breakdown happens. It's a safety net.
Makes sense. Are there other controls like that to prevent runaway problems?
There are also semantic circuit breakers. These are more advanced anomaly detectors, specifically watching for rapid or weird shifts in meaning and intent. They're designed to flag feedback loop instability in real time.
Feedback loop instability. Yeah. Like the AI getting stuck in a bad cycle.
Sort of, yeah. If the internal feedback loops where the AI adjusts based on its own outputs start behaving chaotically because of semantic errors, these circuit breakers trigger immediate containment. That might be a high priority alert to humans, or throttling problematic interactions inside the AI, or even isolating a faulty module if it crosses a threshold. They prevent runaway processes where errors rapidly destabilize the whole system, like an electrical breaker, but for meaning.
It's all about building these layers of self-awareness, self-control, and ultimately safety. Which brings us to this bigger, maybe more profound idea: AI immunology and self-inoculation. Not just fixing bugs, but building lasting resilience into the AI's very nature.
That's really the core goal, the paradigm shift we're aiming for. We're moving towards what the sources call algorithmic self-therapy. The main idea here is equipping AI systems with the ability to diagnose and actively heal their own undesirable behaviors, their own internal issues.
Heal themselves, like AI therapy.
Essentially, yes. It's not just patching a glitch. It's about enabling a recursive AI to escape what are called pathological attractors.
Pathological attractors.
Yeah, think of them as stable but harmful states in the AI's internal model of the world. It's latent space, bad habits it falls into. The goal is to help the AI navigate away from those towards more coherent, adaptive, productive, cognitive fixed points, healthier internal states. The AI becomes its own therapist, guiding itself.
Breaking its own deeply ingrained bad habits. That requires a kind of metacognition, doesn't it? The AI has to reason about its own reasoning, not just execute tasks.
Precisely. Metacognition here means the AI can model its own cognitive processes, observe its own internal logic, evaluate its performance. It needs to be able to recognize explicitly something like, my previous reasoning was flawed because I held contradictory beliefs, or my understanding of this concept drifted.
And then fix it.
And then crucially, fundamentally update its own internal theory of the world to resolve that contradiction or correct that drift permanently so it doesn't make the same mistake again. This is a huge step towards more general, reflective, truly intelligent AI, a system that learns from its logical, maybe even ethical failures and structurally adapts. The AI essentially says, I see why I messed up, and here's how I'm changing my internal logic so it doesn't happen again.
That's profound. It sounds a bit like human self-reflection, maybe growth through therapy. Is there any parallel there, like the therapeutic dialogue?
There's a really interesting analogy from research into AI-enhanced VR for psychological counseling, using AI for self-talk therapy. Studies show an AI, acting as an objective, non-judgmental partner, can actually help humans reflect and work through challenges. It shows the core principles of therapeutic dialogue, active listening, prompting inquiries, spotting cognitive distortions, can be algorithmically modeled.
Okay.
So the powerful implication is an AI could potentially apply these same principles internally to its own processes, engaging in a form of algorithmic self-therapy, observing its own thoughts, identifying inconsistencies, guiding itself towards resolution.
A fascinating, almost philosophical parallel. But how does an AI learn from its biggest failures, its deepest errors? Can it really develop a kind of scar tissue from those experiences that makes it stronger?
Yes, exactly. That's where this concept of algorithmic scar tissue comes in. And it's built through something called death simulation memory.
Death simulation memory. That sounds dramatic.
It does, but the idea is intentionally inducing and retaining synthetic collapse experiences, basically forcing the AI to simulate catastrophic internal failures. Maybe using a prompt chain entropy simulator that just injects maximum noise and ambiguity to push the system to its absolute limits. By doing this, the system builds an exhaustive error of taxonomy and provenance log. It transforms those raw simulated failures into structured, actionable lessons learned, not just a record of failure, but a categorized analysis of how and why the collapse happened.
So the system intentionally faces its worst nightmares, remembers those wounds, and that memory actually makes it stronger, prevents future disasters.
That's the idea. This algorithmic scar tissue is the encoded memory of past injuries and, importantly, the successful recovery routes. It lets the system adapt its future behavior based on past traumas without constant human hand-holding. It internalizes the lessons like immunological memory. And to track this resilience, there's the Dynamic Immunity Window, DIW model. This model quantitatively tracks the system's resistance to specific failure types over time. It can even predict waning immunity, like if model drift makes the system vulnerable to old errors again, and automatically trigger retraining or therapeutic buffering using libraries of known collapse signals and recovery methods. It's like an AI vaccine schedule.
And this all feeds back into making the AI continuously improve itself autonomously.
Precisely. The recursive self-improvement RSI engine drives this autonomous enhancement. It uses that error memory, the scar tissue, the feedback loops to optimize prompts, reconfigure how agents work together, even suggest fundamental architectural changes based on past failures and successful recoveries. It's a closed-loop system of continuous learning and adaptation driven by its own mistakes.
Okay, we spent a lot of time talking about semantic drift as, a problem, something bad to be fixed or prevented. Degradation. But what if?
Yeah.
What if we flip that? What if drift isn't always a failure? Could it sometimes be a path to discovery, like controlled exploration instead of just an error?
Now you're getting into one of the most profound paradoxes of meaning in AI. The idea of reframing failure, not as a bug, but as a feature, a generative affordance. Your sources propose thinking about conceptual erosion not just as decay, but maybe as a speculative ritual for discovery, rooted in the concept of productive misinterpretation.
Productive misinterpretation.
Yeah.
Sounds like an oxymoron. How can misinterpreting something be productive? Isn't that the exact opposite of what we want?
It's definitely counterintuitive. But the idea is that intentionally introduced symbolic noise or maybe carefully controlled ambiguity could actually nudge the AI towards novel, serendipitous insights. Things not explicitly in the prompt or the training data. Think of it as, well, controlled chaos. This meaningful noise might expand the AI's conceptual search space, push it off the beaten path, and productive ambiguity could lead to genuinely new insights, things humans recognize as valuable, while still maintaining some degree of coherence. It's about finding that delicate balance, minimizing the harmful drift that leads to nonsense, while encouraging just enough creative misinterpretation to spark novelty. It's the difference between random, static, and maybe carefully tuned dissonance.
Can we make that more concrete? How might this semantic drift collider idea work? Your sources mention a cross-domain drift recombination prompt.
Certainly. Imagine crafting a prompt specifically designed to force creative tension between concepts, like collide two metaphors with divergent drift trajectories. For example, democracy is a weather system versus democracy is a blockchain of public consensus. Force the model to merge them without collapsing into jargonism. Annotate. The goal is to push the AI to synthesize these seemingly unrelated ideas, forcing a creative semantic collision. It can't just pick one, and it can't just generate meaningless buzzwords.
Okay, that sounds like a recipe for brilliance. Or utter gibberish. What kind of output does that actually produce?
Well, the sources provide a pretty illustrative simulated example of a merged metaphor. It goes something like this. Democracy can be understood as a dynamic atmospheric ecosystem, where collective will and diverse opinions are like shifting winds and weather patterns, creating periods of calm or storm, growth or drought.
Okay, starting with the weather system.
Right. Then it brings in the other metaphor. The fundamental principles and agreed-upon processes act like a transparent, shared record of atmospheric conditions and their impacts, not etched in stone, but a living log, like a collectively maintained natural ledger.
The blockchain idea, but framed naturally.
Exactly. It continues. This record helps interpret the political climate, ensures sudden squalls are understood in context, and allows the seasons of governance to change based on both immediate conditions and enduring agreed-upon patterns, rather than arbitrary gusts.
Wow, that's actually really rich. Nuanced. And definitely creative. It goes way beyond just one metaphor or what a human might easily connect. That really shows how purposeful controlled drift could lead to deeper understanding, unveil new conceptual territory.
Precisely. And this idea even extends to concepts like cognitive fossilization. That's where concepts might decay towards overly stable, rigid interpretations in the AI's latent space, losing nuance. Even that, the sources suggest, could be a starting point. Maybe apply semantic inversion layers to challenge those default assumptions, force a fresh look. It's about revitalizing stale ideas by intentionally shifting perspective.
This is incredibly exciting for creativity, for pushing AI's boundaries, but it also feels like walking an ethical tightrope, doesn't it? If we're intentionally encouraging productive misinterpretation, reframing drift as potentially good, what does that do to epistemic integrity, to basic truthfulness? Especially if this becomes a design principle.
You've hit the absolute crux of a critical, unavoidable issue. There's a fundamental novelty-usefulness trade-off. Pushing a model towards more novelty inherently risks outputs that are less useful or less factually correct. Tightly controlling hallucinations might stifle creativity, sure, but intentionally cultivating coherent hallucination within the AI, even for artistic or exploratory reasons, that raises really significant ethical questions.
I can see that.
If an AI is regularly engaging in controlled misinterpretation, does that leave latent semantic scars? Could it undermine its ability to be truthful when it really matters in medicine, law, finance? What's the AI's moral responsibility if productive misinterpretation is baked into its design? It's not just about filtering bad outputs, it's about the AI's internal state, its fundamental commitment to truth.
So it's not just a tech challenge, it's deeply ethical, touching the nature of truth and AI behavior, which means roles like prompt engineers. They become much more than just technical operators, right?
Far more. They effectively become value shapers, maybe even ethical architects of AI behavior. The act of writing a prompt inherently encodes human values, biases, intentions. If that's not managed carefully, it can reinforce harmful societal biases, spread misinformation subtly, generate content with unintended negative impacts.
Right.
This elevates prompt engineering way beyond just tech specs. It has profound societal implications. It demands conscious ethical design, constant vigilance, and probably a multidisciplinary approach, integrating ethics, philosophy, social sciences, right into the technical practice. It's designing for integrity and responsibility, not just clever outputs.
Designing for values. Okay, we have covered a ton of ground today. From semantic drift and hallucinations to the AI's epistemic immune system, the meta-agents, the interventions, the algorithmic scar tissue, even reframing failure as discovery. But like any frontier, there are always big unresolved questions. Mysteries still out there. What are some of the deepest questions researchers are grappling with now at the leading edge of AI self-correction?
Oh, the frontier is vast, and the questions get pretty fundamental, touching on AI cognition and control itself. One huge one is formalizing the governance of contradiction. How do you formalize a reflexive consensus governance protocol, an RCGP, to dynamically sort out competing interpretations and resolve contradictions that will arise in these complex multi-module AI systems? Imagine an AI with different parts optimized for different things, potentially leading to conflicting internal truths. The RCGP needs to be the internal judge.
An internal parliament or a court for the AI.
Yeah.
Making sure its different voices can agree, not just fight or collapse into contradiction. That sounds incredibly hard to architect.
It is. It means investigating optimal designs for semantic contradiction loop evaluators, things that spot conflicting meanings, and confidence plausibility divergence monitors, things that check if the AI's confidence matches reality. The goal is stopping algorithmic self-sabotage, where internal fights cripple the AI. And ensuring fixes lead to real insight, not audit hallucination where the AI just thinks it fixed something. Designing for genuine internal truthfulness.
Makes perfect sense. What about understanding the shape of how meaning degrades, its geometry?
That leads to the really cool question of the geometry of intent decay. Can we use advanced math, like topological data analysis, TDA, or geometric deep learning, to actually map the evolving intent manifold in the AI's latent space?
The intent manifold, like the shape representing the AI's core purpose.
Exactly. Latent space is that high-dimensional internal map where the AI holds its understanding. We want to map the shape of its purpose within that space. The goal is to tell the difference between recoverable drift, the stuff we can fix, and irreversible purpose fidelity collapse, where the original mission is just fundamentally broken. It involves finding semiotic geodesics, the most direct, coherent paths through meaning and spotting regions of highest drift probability to intervene early. It's about charting the AI's conceptual landscape, seeing where it's stable and where it might slip.
Like a high-dimensional mind map, showing solid ground and potential pitfalls. What about getting better at identifying the signatures of different AI errors?
Yeah.
Right now, it feels like we just see error, not its specific fingerprint.
Right. That's the pursuit of forensic semiotics of algorithmic deformations. Can we develop a formal semiotic algebra to precisely quantify and classify things like hallucinated causality, syntax erosion, or mimic overlay? Hallucinated causality is implying cause-effect where none exists. Syntax erosion is the subtle breakdown of internal grammar. Mimetic overlay is just mimicking patterns without real understanding.
So going beyond, it's a hallucination to diagnose what kind of hallucination, like different pathologies.
Exactly. Finding the unique signatures of statistical correlation pretending to be understanding, or systematic decay of language structure, or superficial pattern matching instead of deep cognition. The ultimate aim is a semantic debugger protocol for probabilistic agents, a tool that tells you not just where an error is, but precisely why from a semantic and logical view, the exact nature of the deformation. Like an MRI for AI meaning.
An MRI for meaning. I like that. Okay, and finally, that provocative idea about resilience, using a kind of trauma to build stronger AI. That sounded intense.
It is. It's the concept of algorithmic PTSD for resilience engineering. The question is, can we subject a digital twin, an identical simulated copy of an AI, to algorithmic PTSD in a controlled lab setting? Expose it to persistent degradation, repeated failures, avoidance patterns from simulated collapses, basically induce controlled trauma.
Why?
The aim isn't to harm, but to develop novel, maybe biologically inspired algorithmic therapies or architectural buffers that speed up its resilience and adaptability before the real AI goes into production, like controlled stress, strength strengthening biological systems, build robustness by systematic exposure to failure modes. Of course, this raises huge ethical questions about trauma-informed AI training. How do you even define harm or stress for an AI? It's complex.
Definitely complex, and maybe the most abstract but foundational question for understanding the limits of AI coherence.
That might be the thermodynamics of semantic collapse. Can we create a formal mathematical model to quantify the work, the computational and cognitive cost needed to resist semantic entropy, to fight the natural tendency of meaning to decay, or to restore purpose when it's lost? This could lead to defining a semantic efficiency frontier, a way to mathematically balance the trade-offs between an AI's ability to generate new things and its ability to preserve meaning over the long term, understanding the fundamental energy cost of keeping an AI coherent and on purpose.
What an incredible journey today. Seriously. We went from the subtle dangers of semantic drift and hallucinations
Yeah.
all the way to this intricate self-healing epistemic immune system. We saw meta-agents detecting errors, triggering interventions, building algorithmic scar tissue, and even considered how failure itself might be a catalyst for creativity.
Yeah, and this deep dive, it's really about more than just complicated AI jargon. It's fundamentally about how we're trying to engineer truly trustworthy, adaptable, genuinely intelligent systems. Understanding these internal audits, these self-correction loops, how concepts evolve inside AI. It's vital for anyone who uses AI, works with it, or is just curious about where it's all heading. It's about building AI that doesn't just crunch data, but truly understands, stays coherent, and can even grow from its own mistakes.
So let's leave you with a final thought to chew on. If AI systems can develop metacognition, learn from their own logical failures, structurally adapt to prevent them, what might that teach us about our own human capacity for self-correction, for growth, for maintaining our own epistemic immune system in a world that feels increasingly complex and, let's face it, often confusing? What stands out to you from this deep dive?